Welcome to lesson 4.3 part 1. So today we're going to be learning about elimination. So this is our last method we use to solve systems of equations. So we've done graphing, we've done substitution, and now we're doing elimination. So there's a few tricks with elimination. So you got to think we're trying to eliminate something. So when we're doing this, we're trying to eliminate one of the variables with addition and subtraction in order to solve it. So if we have coefficients that have the opposite sign, we're going to add. Okay, so let's kind of open up and look at that. So I have 3x plus 4y equals 2 and 4x minus 4y equals 12. So what we're looking for is if they have the same coefficient. So if you notice, these have the same coefficient, right? They're both 4s. So that's kind of where we're going to eliminate. That's where we go, okay, we can eliminate. Okay, so now we notice that one is addition and one is subtraction. So because they have opposite signs, we're going to add. So we're going to add our things, okay? So 3x plus 4x is 7x, okay? 4y plus negative 4y cancels out. It's 0, okay? Equals 2 plus 12 is 14, okay? And then we just finished solving for x, so we're going to divide by 7. And so x equals 2. Okay, so once we do that, we have to find y. So that means we're going to pick one of the equations and substitute x equals 2. So I'm going to do 3x plus 4y equals 2. So 3 times 2 plus 4y equals 2. So that's 6 plus 4y equals 2. So 4y equals negative 4 because you subtract 6 on both sides. So y equals negative 1. Okay, so now that we have our x and y, the solution is 2, negative 1. So we would say this system is consistent and independent because there's one solution. So again, when we're looking for variables that have the same number in front of them, so the same coefficient, and we have to see, okay, if they have opposite operations, so one's being added, one's being subtracted, then we add the systems, okay? And so we're just doing like vertical addition, essentially. So let's look at the second one. So I have 3x plus 2y equals negative 19, and negative 3x minus 5y equals 25. So if you notice, these two are the same coefficients. They're just opposite signs. So that means we're going to add. Okay, so 3x plus negative 3x is 0. It cancels out. Okay, 2y plus negative 5y is negative 3y equals negative 19 plus 25 is 6. Okay, so you're just literally doing the vertical addition every single time with elimination. Okay, so then you're going to solve for y. So you divide by negative 3, and y is negative 2. Okay, so once you find y, you have to find x. So you're going to use one of the systems, plug in your y, and solve for x. So 3x plus 2y equals negative 19. So since y is 2, or negative 2, I have 3x plus 2 times negative 2 equals negative 19. So then I have 3x minus 4 equals negative 19. So then I'm going to add 4 on both sides, and so that's going to be negative 15. So x is negative 5. So my solution is x is negative 5, y is negative 2. So we would label this system as consistent and independent because it has a solution. There's only one solution. Okay, so then the next one is if we subtract, we're subtracting if the coefficients have the same signs. So if they opposite signs, you add. If they're the same sign, you're going to subtract. Okay, So we look here, I have 7x plus 4y equals 2, 7x plus 2y equals 8. So if we notice, we have 7x and 7x. Both of them are positive. Remember, we're trying to eliminate something, so we have to get it to cancel. If we add those, 7x plus 7x is 14x. That's not getting us anywhere. So we have to get rid of it. So we have to subtract to get rid of it. So 7x minus 7x is 0. And then 4y minus 2y is 2y equals 2 minus 8, negative 6. Okay? So whatever you're doing, adding or subtracting, you have to do it all the way across. Okay, then you're going to divide by 2, and y is negative 3. So then you're going to find x. So you can pick either one, 7x plus 4y equals 2 or 7x plus 2y equals 8. It doesn't matter. I'm going to do 7x plus 4y equals 2. So 7x plus 4 times negative 3 equals 2. So 7x minus 12 equals 2. So you're going to add 12. So 7x equals 14. So x equals 2. Okay, so the solution is 2, negative 3. So we would label this system as consistent and independent because there's one solution. If you look at these, some of you are like, well, I like graphing or I like substitution better. These would not be ideal for substitution or graphing. They're all in standard form for graphing, and they don't all graph evenly, or you're going to have a bunch of decimals. Like, you don't want to graph 2/7 on the x-axis. Like, that's not fun to do. And then substitution, you would have to rearrange them, and because neither of them have a variable with a coefficient of 1, they're not always ideal to use that with. So that's kind of where you have to use your math knowledge of, okay, which method fits this idea better. Because sometimes substitution is the best one, sometimes graphing is the best, and sometimes elimination is the best. There's not a one-size-fits-all. You can technically use the method for any of them, but it sometimes takes more adjustment than others to do it. Okay, so now let's look at the next one. I have 2x minus 3y equals 9 and 5x minus 3y equals 30. So if you notice, I have minus 3y on both of them. So I am going to subtract, because if I do 3y plus negative 3, or negative 3y plus negative 3y, that's negative 6y. So that's not going to cancel out the 3y's. But if I subtract a negative, then that turns into addition, and negative 3y plus 3y is going to cancel out. So remember that double negative rule. If you have a double and a negative, you're really adding. So 2x minus negative 5 is really 2x plus 5x, which is 7x. Negative 3y minus negative 3y is negative 3y plus 3y, which is 0. And then 9 minus 30 is negative 21. Okay, so then we're going to divide by 7. And x equals negative 3. So then the next thing we have to do is find y. So we're going to pick one of the equations. I'm going to pick 2x minus 3y equals 9. It doesn't matter which one you pick. It does not matter. So 2 times negative 3 minus 3y equals, not 6, sorry, 9. So negative 6 minus 3y equals 9. So we're going to add 6 on both sides. So that's negative 3y equals 15. So y equals negative 5. So my solution is negative 3, negative 5. So this system is consistent and independent because it has a solution and it's one solution. So now if you have both coefficients lining up, like they both, on x and y, they both match, you can do either. It doesn't matter. Whichever one you decide to cancel out is fine. So when you have either signs, you can use either one. You can use add or subtract. And so this is what this means. So when we're looking at this, we're going to do 1 with addition. It's the same system. And if whichever way we do it, it's going to end up the same. Because I have 2. So here I have positive x's. And then here I have opposite signs. So when I have the same sign, I would subtract, but when I have the opposite sign, I add. So either way you do it, you're going to end up with the same answer. So for this, we're going to add, sorry, I messed up my colors. We're going to use addition first. So we're going to add here, and then this one we're going to subtract, and we're going to see what happens. Okay, so x plus x is 2x. Negative y plus y is 0. And then 1 plus 3 is 4. Then when I divide by 2, x is 2. So then I need to find y. So I have x plus y equals 3. So 2 plus y equals 3. So y is equal to 1. So my solution is 2, 1. Now, you should end up with the exact same solution the other way, okay? Because it's the same system, so you should end up with the same solution. We're just solving it a different way. One we're using addition, one we're using subtraction. So for this one, the first section, the y's canceled out, and we got x first. Here, the x's are going to cancel out, and the y, we're going to solve for y first. So x minus x is 0. Negative y minus y is negative 2y. And then 1 minus 3 is negative 2. So then we're going to divide by negative 2, and y equals 1. So then I have find x. I have to find x after I find y. So x minus y equals 1. So x minus 1 equals 1. So I add 1 on both sides, and x equals 2. And so my solution is still the same. It is 2, 1. We can only do this is if both of them have, so if one of them, they're all the same coefficient, like the x's are the same and the y's are the same, then you can decide I'm going to add or subtract depending on if they have opposite or the same signs. That's a kind of a special case. That's not typical. Typically, you're going to hang out in these top 2 sections, but the third section can happen, and it's kind of up to you which one you want to do. So that's it for part 1 of lesson 4.3. Bye.